Welcome to Happy Homes and Gardens. I'm your host. My name is Daphne Royce. I am a real estate broker, architecture, and interior designer. SpaceX, Blue Orange, and Virgin Galactic has all sent civilians into space since 2021. However, there are more than 47,000 pieces of debris flowing through our orbital space. Space debris is a major problem since these objects can be dangerous to humans and satellites. Kall Morris is a co-founder and director of operations at KMI and will discuss what his company is doing to address this problem. How are you, Troy?
I'm doing well. Yourself, Daphne?
Doing well, thank you. Please tell us who you are and what you do.
Yep, so I'm excited to be here today. So I come from a background of commercial sales, before that in education in psychology, really thinking about how do humans think not just themselves, but as part of larger units. And that has led to my successful commercial sales career before this, and now entering aerospace in the last half decade here to where we are with KMI. So at KMI, we are a space solutions company. As you kind of stated there, we are focused on removing orbital debris, both the legacy assets that have been there for decades and decades, and the new hiccups and mistakes and actions that happen as humanity continues to extend our reach into space. We've recognized that we need to be having the capabilities up there that we do on the ground to grab and relocate objects, even if they weren't fully designed for that. So KMI brings hardware, software, and some mission use case planning. And so we're excited to tell more here today. But my role directly as director of operations is to engage with our customers, our contracts, and really just engage with the public and help understand all these interesting aspects that all go into our everyday space are really supported by this almost hidden foundation of people like us working to protect it.
Great. Can you tell us some backgrounds how KMI started?
Yeah. So KMI has three founders. There's myself, Adam Kall, where we get the Kall and Kall Morris, Austin Morris, who were originally freshman year roommates back in their undergrad, and then myself, Troy Morris. Now, Adam and Austin were freshman year roommates, and Austin and I were brothers growing up. So already we had some closeness, some bonds, but over the last nearly a decade since we met back at Northern Michigan University, the three of us have worked on separate projects. Adam spent time at NASA Goddard doing artificial intelligence, machine learning. Austin was doing time with the Army and DoD on rapid prototyping. Myself doing commercial sales to 17 million a year. But in between our independent successful careers, we kept in touch, and we realized we want to do more. We want to make this positive dent on the universe. And while we were aerospace adjacent in all of our roles, we couldn't quite make that improvement to the world alone. So we formed together in November 2019. Turns out 2020 was a very hard year to be a startup, but we survived. We bootstrapped. We relocated actually from New York, Philadelphia, and Chicago, moving the company back to where it's located now, Marquette, Michigan, where we originally met all those years ago. But that's kind of how KMI got started. Is we wanted to do something in aerospace, and we saw from all the new opportunities coming on market, all the new things that were being developed in the labs, being pushed out on big press releases. If you were to take all these pieces, parts together, we could solve some problems that had yet to be solved in space. And one of those foremost in our first project is orbital debris. So it's bringing together a lot of new technologies or technologies that are just about ready to be utilized and bring those all together to solve the problems we are.
Why in Michigan, and what are the organizations that KMI works closely with?
So we have close relationships with a long list that I would get wrong if I tried to list off everyone. Some of the most major players is our connections with NASA at multiple centers, but chiefly NASA Goddard out in Greenbelt, and then down in Huntsville is also NASA Marshall. So great close working relationship with individuals at both of those centers. Additionally, U.S. Space Force, primarily through Air Force Research Lab and the SpaceWorks group. But we've also had some great engagement with Spock, SSC, some of the Deltas operating out of Colorado. So those help give us some great buy-in from what's happening in the civilian space world, the defense space world, but also policy of space. The National Space Council, the Office of Space Commerce, and some specific individuals I won't name by name here today, but really working close with them so that we at KMI and with our colleagues in the industry are bringing together a collective holistic solution. It's not just a NASA-born solution or a Air Force problem. It is something that impacts everyone. And so we work with everyone on that. And then on the commercial side, Confers is a huge leading element for anyone interested in orbital services. The Confers organization is a great industry-led organization to discuss these ideas and terms and standards that we all need to operate in space. The same way that, cars can all use the same fuel here on the ground. Well, let's make sure that we have some standards so there's not 900 different solutions in space. And so working with some of the members there and outside of them, including NanoRacks, Voyager, Lockheed, Airbus, Northrop, conversations with a lot of new space companies, Cislunar Industries, Orbit Fab, Inversion, the list just goes on, and academics are just nearly as important. University of Michigan from our home state, Stanford, University of Southern California, MIT, working relationships with all those and others. So who we work with is a long breadth of an answer, but we came back to Michigan because it was where we had all met. We had really fallen in love with the city. None of us were natural born Michiganders, but we recognized the high quality of life, the affordable cost of living, the history and continuing development of innovation in the area. And it was just, it felt right. And we've gotten significant support from the state and local communities to stay there. So anytime we try and get poached by Albuquerque or Colorado, we're able to safely defend and make a business decision to stay in Michigan. So we're part to be, of the Great Lakes, and pure Michigan might be their motto, but dang, it is pure Michigan of what kept us there. We could have moved elsewhere, but we really like being in Michigan. So that's who we're working with and kind of how we got to Michigan.
I didn't know you involved with so many different organizations. This must be a big task. So what is keeping space clean so important? And what kind of threats we are talking about here?
Yeah, so we even have it as our initial model for the company. We formed KMI and we realized early on keeping space clear for all is more than just a motto. It's catchy, it's a good hashtag, but it's so important because humans rely on space every day. If you've already eaten breakfast this morning, you've utilized space probably more than a dozen times. Everything from checking weather, GPS navigation, to using a fuel pump, planning a flight, taking a flight, ordering breakfast, using an ATM. So many of these elements that you might not even think about that aren't, well, I'm not, Skyping with someone across the ocean. What do I use space for? Every day. And we're only doing more of that. There's new technologies, there's new medical devices, there's new programs, there's so much new coming down from space to help us here on the ground. That isn't just the information I talked about there before. All of it, every single bit is at risk to different levels through the threat of orbital debris. Because this debris is moving at orbital speeds of 17,000 miles per hour. So even a small piece the size of, a screw or a dropped bolt could smash through that satellite that you were using to order your Jimmy John's on. That's not a good day. Now they can't be freaky fast if you never get the order through. So it's something that, these threats are just continuing to grow. It's an exponential growth problem where if humanity worldwide stopped launching today, the amount of debris by number is going to continue to increase because we already have so much up there. So at this point, it's less of like trying to keep every single aspect clean, but just starting with those initial pain points is what are the crucial satellites or crucial missions or, the ISS orbit, a crewed orbit that has human lives on the line every single day. Those are priorities. Those are the areas we need to focus on keeping clear. And the threats we're talking about are both those small little, paint flecks and pieces of bolts. But by and large, it's the large rocket bodies. If you're to talk about dangers on the ocean, yes, small little pieces that might hit your ship could be bad, but it's the icebergs. That's what brings down the Titanic. And even if it's not these rocket bodies that hit an object themselves, once they get struck by a piece of debris, they then become hundreds or thousands of pieces of debris themselves, just continuing this terrible snowball or domino effect. And that's where our priority is really focusing on these known state, out of use, dangerous rocket bodies. And we've developed with a lot of our partners the technologies and aspects to go and retrieve those objects before they become the next crisis event.
How fast are things moving in space, and how do you capture space debris at high speeds?
Mhm. So for everyone who remembers, their intro to physics class, relative speed is the key of capturing up to something that's moving at 17,000 miles per hour. Many times when you're talking space traffic, things are measured in kilometers per second. And it's hard for the human mind to boggle and to, wrap your head around that high speed. But as you move your own object, again, back in intro to physics, as you move your own object up to a similar speed in similar directions to that object you're chasing, it's no longer that you're whizzing past each other, many times faster than a bullet. It's now relatively close speeds. It's like catching up to a, tanker truck on the highway. He might be going 70 miles an hour and you're going 72. Well, now you can gain and catch up to him, and at a much grander scale, that's what happens for orbital debris, what's called rendezvous. It's a hard problem because you're not just moving forward along, the 101, you're actually, moving in multiple planes of existence. So moving through those multiple orbits and multiple avenues, or what are called axes, is where we then use that software that KMI has developed called TumbleEye. This allows us to characterize, kind of know what that object is moving like and move ourselves in a logical positioning to catch up with that object. Then comes the other fun part of, okay, you've reached an object, how do you hook on? And at KMI, we've also developed with a number of our partners, chiefly University of Southern California, USC, working with them to develop a technology called REACH. This is our technology that's going to be going to the International Space Station in 2023. And that technology is to non-destructively secure along the unprepared surfaces of an object. So if you're just listening to this at home, imagine, a caterpillar leg unfurling or an octopus leg slowly unfurling to really capture around an object and use a number of technologies within each one of those linkages so that we can secure an object and now move it to a safer location. So it's not simple, but we try and keep it easy for people to understand. It's a hard mission with dozens and dozens of engineers and hundreds of hours of thought, but it's a mission we're working on with a number of, frankly, genius partners around the world.
What do you exactly use to capture debris in space?
Yep, so to capture debris would be first a rocket to get us off the ground. Then our spacecraft would move us towards the debris object. Let's call it a rocket body to keep things simple here. Then we'd be using that TumbleEye software I was talking about to figure out the tumble of that object and kind of, GPS give you how do we have to move to get close to that object. And as we get close to the object, that's where we'd use that reach technologies, those mechanical linkages to unfurl, not too dissimilar from a human hand, grabbing a water bottle or a large can of soda, but just a little bit higher tech and not quite as limited to the few knuckles we have on our hands. So it's able to use 8 arms with 10 linkages. And that's giving us a high spread of adhesion ability so that we're able to secure the object. And then from there, after we've secured the object, we detumble it if necessary, because it might have been careening in crazy ways. We can then relocate the object with our spacecraft and push it towards a junkyard orbit, a graveyard orbit, or push it for a controlled reentry into the South Pacific. So there's a number of options depending on what the object is, who owns it, who wants to move it, and where they want to move it to. So as we answer those questions ourselves with customers and with regulators, there's generally those few options: graveyard, scrapyard, or into the ocean.
So where are those graveyards, scrapyards that you mentioned about in the space?
Mm-hmm. So the most famous graveyard orbit is one that exists around the geo orbit. So for those who aren't heavily familiar in your orbits of Earth, you've got the Earth's atmosphere goes to about 100 kilometers from the surface of the planet. From 100 to 1,000 kilometers, what's called LEO. This is where the ISS is, shuttle missions, all that good stuff you think about most of the time. Then at about 10,000 kilometers, you've got MEO, middle Earth orbit. And then even further, somewhere around 36,000 kilometers is geosynchronous orbit. That orbit is where GPS, communication satellites, a lot of the big, massive satellites that have launched in Earth's history reside. And early on, humanity figured out that in this very critical, very specific orbit that goes around the Earth at the same rotational speed as the planet down below it, we have to take care of it. And so groups around the world back during the Cold War started agreeing, okay, if you're not currently operating in GEO, we want you to move a little bit further out into this graveyard orbit, a purposefully unused orbit that's just beyond GEO, so that we can have things stored for later. Later, somewhere, our generations will figure out how to clean up. And we're approaching that point with KMI and others that we could go out and actually retrieve those objects in graveyard orbits. In LEO, it's not quite as nicely defined. In low Earth orbit, it's a little bit more Wild West than organized council of gentlemen. So there is some orbits that have become de facto junk or scrapyard or graveyard orbits. But as we get into our missions in 2025 and working with a number of partners developing their own technologies, we're looking to be placing some of these scrapyards kind of similar to the ISS. They wouldn't be at that same orbit, but they would be following these major orbits of debris at a nearby distance like the graveyard orbits are today. So the analogy I make for those trying to wrap their heads around it is, you never put your car scrapyard or recycling center right in downtown or right on the highway, but you put it pretty darn close, so that as you need to recycle something, it's a short distance to go in and do that mission work that needs to be done. So the scrapyards aren't there yet, but there's some great mathematics being developed by KMI and MIT to give you an exact location. So stay tuned.
So how big an orbital space that KMI service in space?
Yep. So initial missions are focused on the LEO orbit, that 100 to 1,000 kilometers. By mass, there's plenty of material for us to go after. If I remember one of our briefings right, it's about 10 million kilograms of material that is within that operational range that could be repurposed, recycled, reused some way in orbit. Beyond that, you've got a large mass of objects out at GEO, but rather a low quantity because most of them are very well maintained. And then there's some other special orbits that are happening here and around everywhere, MEO, HEO orbits, a lot of specialty orbits that come in for there. But our focus is LEO. 1, it's reachable. 2, it's where a lot of the problems are. And 3, to get to any other orbit, you have to go through LEO. So if you're trying to get to the moon or Mars or out to GEO, any spacecraft crew or uncrewed has to go through LEO. So if we accidentally turn that into a minefield of millions of pieces of small lethal debris, it doesn't matter what cool tech or cool places we want to go. We're stuck in a cage of our own making. And that's one of the driving factors for KMI focusing on that LEO environment.
It sounds like when you walk into the house, you go through the foyer, and that's where you clean up before you clean up other rooms.
Exactly. LEO is the mudroom of our planet, and it has not been swept. No one's brought a mop in there in decades. It is a mess right now. But yeah, it is the foyer, the mudroom, I guess for I should have been using more housing examples for your background here, but yeah, exactly right.
And in 1969, the first person landed on the moon. Do you know how early we started to accumulate objects in space?
Yeah, so objects in space, there's been some claims to earlier objects during World War II from some of the rocket programs von Braun was doing over in Germany. There's been theorizations for a manhole cover that was done during Manhattan Project to launch into space, but the first true orbital object was Sputnik. October 1957, it entered a controlled orbital path around the planet and continued for quite a while. It wasn't the first what I'd call debris though, because it came back down because humanity was just figuring out how the heck do we put something around our planet. Months later though, in March of 1958, is when we had the first permanent object that we've seen, Vanguard 1. So Sputnik was launched in October 57 by the Soviet Union, and the United States launched just, 6 months later, 5 months later, Vanguard 1, and it's still there today. So in the worldwide catalog of space objects, Vanguard 1 is object number 5, because there's, the rocket that launched Sputnik, Sputnik itself, some other pieces there, but Vanguard 1 still continues. So we've had debris in space much longer than we've had men or women in space. And I'm afraid that if we continue that path, we won't be able to get anyone up there. So it's been a long time that we've had these objects in space.
Is the Vanguard 1 still in working condition today?
It's not in a working condition. I believe it was last having contact somewhere in the mid-60s, which was outstanding. I think the initial project was planning for 3 months, 90 days of contact. And like we've seen on some of the scientific missions to Mars, sometimes these projects just keep going. But it's also in the late 60s that we started seeing this, gold rush of launches from nation states where they were launching rocket after rocket after rocket. And at that early time, space was infinite. How are we ever going to fill up outer space? It's like if we were to take the entire Pacific Ocean and quadruple it, what do you mean we're going to cause this debris problem? So a lot of the rocket bodies that we still see today launched from, the late 60s, the early 70s. And so those are the rocket bodies that we're chasing after to this very day. Thankfully, most modern operators launch responsibly. And there's actually an open letter that just has begun circulating this week. KMI is one of the signatories for a more universal approach of controlled reentry of rocket bodies, that we don't make this problem worse. We at least put away the boots and coats when we come in the house now, even if we haven't been doing it for the last 60 years. So yeah, it was operational for quite a while, and it's led an interesting life for Vanguard 1, but also the rocket bodies that came after it.
How much time do you need to remove 47,000 pieces of debris from space?
Yeah, so this is a wonderful question that I get, because we could run down the math of if you wanted to remove every single piece, it could take decades, hundreds, thousands of years, depending on how fast you want to go, how much money you want to put into it. So it's the same of if you want to chop down a whole forest. Well, is your goal to really remove all the things from that area, or is it to make it that you could, in the forestry example, put a road through? And it's the same thing for space. We don't need to, by humanity, remove every single piece one by one. The priority is first removing those problems, and then also those high-risk objects. There was a great paper done by J.C. Liu, Don Kessler, who's the kind of unwilling grandfather of orbital debris research. His name is born on the Kessler syndrome, where if humanity doesn't do enough and enough of these debris objects hit, it becomes this unstoppable cascade of collisions, and prevents humanity from reaching space. Well, in 2010, him and some colleagues discovered and did the math that 5 or 6 significant objects removed a year would plateau that amount of growth that we're seeing. So rather than ever increasing numbers of debris, removing those 5, 6 objects a year would do a good job of keeping us at a normal state. Obviously, that's still too much debris because we're having to avoid it all the time, and there's other impacts. And we've put up far more objects since then. But even if it's 10 objects a year, 12 objects a year, humanity doesn't need to do a whole lot in this equation to at least maintain a survivable level. More objects we remove, the better the situation becomes. But yeah, the question of how fast can you remove 47,000 pieces is how fast do we want to do it? With the right focus, I mean, humanity was able to get to the moon decades after we figured out how to do flight. Now it's taken us another 50 years to get back to the moon. So scientific progress always has interesting timescales. But for our KMI spacecraft, once we get into orbit and grab a first piece of debris, we're also having the fuel and the technology to grab additional pieces of debris. So it's not, one truck goes out and removes one dumpster worth of garbage. That's never efficient. You need to be able to do multiple. And so our spacecraft can remove 4 to 7, maybe even 9 significant objects of debris in space, depending on where they're located, and a lot of important qualifiers on that statement. But it's crucial to understand this is a problem that could be solved by 1 or 2 spacecraft per year. And that's something we don't often see in worldwide tragedies. You don't see a wildfire being able to be stopped by 1 fire truck. It's thousands of people working millions of hours to try and stop these tragedies before they become catastrophes. And in space, as much technology has got us into this mess can also be the benefit that gets us back out. So for time, I don't like to focus on the trying to remove every piece, but of trying to keep humanity functioning as we are. It's 1 spacecraft being able to do those multiple missions.
So how many KMI spacecraft you are going to send to space, and how big is your spacecraft, and what is the largest piece of a scrap that you can grab from the space?
Yep. So I'll work with those questions backwards. So the scale, the size of objects that we can go after, it could vary. We can build slightly larger models if we're going after a specific thing. Let's say we're going to relocate the Hubble. It's a larger object than what most things in space. Our general parameters is the length of a moving truck. So, about 18 feet, or the more specific number was 6.5 meters. And then as we work down to the small scale, it's something that at that size, we're looking at 250 millimeters, so 0.25 meters. So that's about the size of a basketball. So it's a large margin of things that can be captured with those arms because of the way they articulate. The spacecraft itself is relatively small. It's below 200 kilograms. It can go on a rideshare rocket from SpaceX and a number of other launch providers. For those at home, it's about the size of a gym bag. A very, very expensive, delicate, super specialized gym bag. But the innovations in the aerospace industry have helped us all move away from needing these massive school bus size specialized spacecraft to do every mission. So we're happy to be part of that tradition of doing it efficiently, both for time and cost. And then I think your first part of that question there was how many? And that's a scaling question over time. Initially in 2025, KMI has the planned first launch of our spacecraft to go remove a piece of debris. And shortly thereafter, launch the second and the third. The only issue we'll run into is that because we're doing constant burns largely of our missions of going after different pieces, not really waiting there and just collecting data over 10, 20 years like most spacecraft, they won't have relatively long lives. They're working on the mission, and once they're at the end of their life, they'll re-enter the atmosphere or go into the recycling centers themselves. So we're planning to have, I think the numbers were about 6 or 7 spacecraft launched by the end of the decade. And as in-space refueling becomes a reality, we figured out other efficiencies, we'll start to see multiple spacecraft operating at once. But from the customer-driven demand we've seen and from some of the science I mentioned before of having to remove so many objects per year, even just having 1 or 2 operating a year can be efficient enough to keep space clear for all. But the more missions we can be doing at once, the better for everyone involved.
What fuel does KMI spacecraft use, and how long can the KMI spacecraft stay up in space?
Yep. So the fuel we're intending on right now is the high efficient electric propulsion of xenon. It's stable, it doesn't explode, so that's really nice for a dozen reasons, and it gives you that more of a marathon pace rather than a sprinting pace. The negative of that is that as in-space fueling becomes a reality, we'd want to be switching to that available fuel, because even if a different fuel is less efficient, having an almost endless supply of it at hand, it doesn't matter how efficient you are. If you have endless, bottles of Gatorade to keep letting you sprint 100 meters at a time, that's way faster. So right now it's going to be xenon Hall effect thrusters. There's a great company out of Michigan, Orbion Space Technologies, another Michigan-based space entrepreneur group, and they're doing some fantastic work there. So it really gives us the ability to leapfrog and move faster and further than if we had to create each aspect of these technologies ourselves. So by taking, again, a ride share of rocket scientists that we don't have to figure out, and using a spacecraft using propulsion from another great group of scientists we don't have to figure out, we're able to stay in space anywhere from a few months if we were just extremely aggressive on going to retrieve objects, anywhere up to 12, 18 months. It's something that, again, these mission plans are not to be long-standing, lingering spacecraft like most satellites are, but it is something that we've had some discussions with customers of, hey, we want your KMI spacecraft to stay around as a guard dog, a chaperone for our spacecraft, so that if there becomes a piece of debris that's going to be in our way, you could go and defend it. Like when you see large trucks with massive pieces of machinery moving down the road, they often have a lead truck, a lead vehicle to make sure they don't hit that bridge. So we'd be doing a similar role for important, anything from a NOAA satellite that tracks for hurricanes, a crucial ability for millions of Americans every year, to communications, to Lord knows what else. So it's something that time scale is continuing to expand as customers come to us with different ideas, but it's intended overall as a relatively short mission.
Do you perform any space traffic control?
My normal answer to this is no. There's a few acronyms that have been used in this field: space domain awareness, space situational awareness, space traffic management. So in any of those 3 categories, largely no. We were relying on operators. There's one based out of Michigan, Atlas Space Technologies Ground Communications. They're entering that field, but there's also, Leo Labs, Privateer, Capella, Slingshot, 5 other more that I don't have off the tip of my tongue here. And so there's a lot of great new technologies, innovations, all building off of what the 18th Squadron was doing for free. Spacetrack.org was a great way for most people to operate and figure out where are things in the sky. But as we get more and more action up in space, missions like ourselves that need to really not be in the neighborhood, but be exactly in the right spot, it becomes important. And there's great groups working on the $1.8 billion space domain awareness market. And we're not looking to enter that ourselves. It's something that, space traffic control, I mean, would you consider a tow truck part of the police? Well, for some crowd control, sometimes they maybe have to move a dead car out of the way so that the parade can run through. So it's something that we work with those in space traffic management. And it's something that even our platform is in conversations to serve as an in-space sensor so that we'd be able to relay the amount of information of things going around us at that time. But no, at this point, KMI has no dreams, visions, or roadmaps to get into that very important and very competitive field. But we are greatly benefiting from all those who are fighting for the lead right now. So keep going.
Out of curiosity, once you grab the debris from the space to the salvage yard or scrap yard, how would you control those debris stay in the same location?
Mm-hmm. So that's part of the benefit of things moving so fast in space is their initial inertia. It's that double-edged sword. These objects are relative to the ground, moving 17,000 miles per hour. But in space, once you place it in the correct sequence of orbit, based on those 6 axes, they largely stay in their position. That's the same reason, for better or worse, Vanguard is going to stay up in orbit for another couple hundred years. Is once you're placed into a relatively circular orbit, we follow to Newton's laws that an object will not impart force unless it's acted upon by an outside force. In space, especially in Leo, there's very little atmosphere. It's hopefully not going to hit anything. That's why we're moving it to a better location. And the small impacts that we do see in space, solar wind, atmospheric fluxes, are relatively minor. So most of these rocket bodies were an afterthought. After they put their mission into space, no one kind of cared where they went to. We're coming in now to organize things a little bit more. Rather than the boots kicked off by toddlers into the corner because they want to go play or watch TV, we're going to organize, put them in the right spot there in the foyer, and from there, they should be in that same spot. Again, I've oversimplified this as I have many aspects of this conversation, but by placing it in that controlled orbit and the gentle release our technology allows, the rocket body could either be there just by its inertial continuation, or we've had discussions for having a leave behind technology, attaching an actual fixture to it so that, like a boat tied up to a dock, it might float a few feet this way or that, but largely it stays in the same spot. And that's probably what we'd like to do if we're doing some sort of in-space recycling, is have things semi-permanently attached. And so that's one of the projects KMI is actually working on with the US Space Force through their called Orbital Prime program, is looking at some of those technologies. So it's a good question. How do you make sure something that you just spent all this time, all this effort to capture doesn't just kind of float away? And luckily, space isn't nearly as floaty as George Clooney and Sandra Bullock make it look like in Gravity, but there's still some hurdles to overcome there. So we're working all we can to make sure every step is safe, controlled, and for the best action of everybody.
And have you mapped out how many scrapyard locations is ideal for the space currently?
So the ideal number is something that's being worked on, because the optimization math requires not just locations, but cost. If it cost you nothing to put a recycling center, I mean, you'd have one at the end of everyone's driveway, but they do cost something. And so that's the number that's really still getting figured out. That's another one of the contracts we're working on, is working with mathematicians, space station providers, multiple of them, because that's the reality of this year, 2022. There's now multiple space station providers. So working with some of the commercial LEO destination groups, some of the groups that have newer innovative designs, we're working on that optimization number. Unfortunately, at this time, I don't have a great one. Our early guess, our early estimations are going to be, there'll likely be a station for sun synchronous orbit. There will likely be one for polar orbit, likely one for an equatorial orbit, and maybe one that's kind of mirroring what the ISS is doing today. There's actually even been a white paper proposing recycling aspects of the ISS once it's completed its lifeful usefulness, and rather than disposing of it into the Earth's atmosphere, using that as the first scrapyard. So we were one of the co-authors of that white paper. I was actually picked up, I think it was Politico Pro in the last week or so here, and good Christmas present for us. So there's a number of options. Time will tell if, the science says we should build 7, but the cost says we should only build 3. That's why we're focusing on building a priority list of where's the first scrapyards we want to do. So it's going to be a few, but it's never going to be something in the hundreds of thousands. You're not going to see recycling yards like we see Starlinks. It's just a different economics issue, but I mean, there's even been discussion, what if you just had a Starlink specific recycling center so that as those very similar spacecraft fall out of disuse or break down, it's very simple to recycle. It's like, how soda cans and beer cans are basically the same size. At the recycling plant, that makes things easier because you just have one size to worry about. So time will tell on the more exact numbers there as we go on.
Would you ever want to visit space yourself?
Absolutely. It would probably take longer for them to point which place I put my suit on than for me to agree to go with it. I've been a fan of space since I was a small child, like many. And actually, in my office, I still keep the first space toy I ever got. 6 years old, a unfortunately very inaccurate little spaceman. Now that I've spent almost a lifetime here looking at space, interested in space, and speaking with actual astronauts, crew on the ground, I've learned more and more of how many assumptions I had wrong at 6 years old and how many I had so darn right. So it's something that my path was probably never going to be through the astronaut corps. I'll likely, if I ever get the chance to go to space, as a tourist. I'd love to do scientific missions, but I'm also, like my brother and Adam, all 3 of us co-founders, we're a little bit taller than the standard astronaut offerings generally cut off at. So we're really excited that we're seeing some of these missions where Michael Strahan, a football player, if he can go to space, I think us tall gentlemen should be able to get a seat right next to him. So yes, you would have a hard time telling me that I couldn't go up there for a day, a week, a month. Longer than that, I mean, that's a long vacation in an atmosphere that you have to work out half the time. So space is something I would definitely go to, and I'll take anyone's offer for a free ride. So always welcome for that part.
I hope you do one day, and let me know what's it like.
We'll do a catch-up follow-up interview then.
Absolutely. I would love to. Well, thank you, Troy, for all your time today. And that was a very informative information for my listeners. Yeah.
If anyone would like to learn more, they can come to our website, www.kallmorris, KALLMORRIS.com. You can also find us on the social medias. We're active with a number of our partners, and we're happy to continue the conversation. We've had presentations we've made for school children, for high schoolers, for collegiate students who they can grill you on some good questions, to industry partners, some in terrestrial-based recycling, others who have technology that might work with us, and again, just lifelong space fans. So I never hesitate to offer up, come contact us, find out more, learn more about KMI, and let's work together keeping space clear for all. So Daphne, thank you so much for having me, and I look forward to meeting with many of your listeners hereafter.
Wonderful. I will link your website information to the video as well.
Thank you so much.
Thank you.
Have a great day.